Welcome to another edition of A for A Levels. Today, we're going to go through Pure Maths Paper 31 Summer 2020. Welcome to my tutor. Let's go. Find the set of values of x for which 2 times 3 to the power 1 minus 2x is smaller than 5 to the power x. Give your answer in a simplified exact form. So the exact form, we must put it in terms of logarithm. So this is an exponential inequality. Exponential means the unknown x as a power. So in this instance, you need to log both sides of the equation. Okay, now before I put the logarithm, I'm going to put everything in x first. 1 minus 2x. So 3 to the power 1 minus 2x is 3 to the power of 3 over 3 to the power of 2x. So this is 2 times that. Okay, so by multiplying by 3 to the power of 2x, it is okay. It is okay to multiply by 3 to the power of 2x because an exponential is always a positive value. So you have 6, 5 to the power x times 3 to the power of 2x. Okay, so 6, 5 to the power x times 3 square times 3 to the power x. The reason why I'm doing this is because of this 3 square. Yeah, 3 square. So I'm going to divide by 3 square, which is 9. This 5 to the power x times 3 to the power x is, when you have the same power, you can multiply the base in the power of x. Okay, so 15 to the power of x larger than 2 over 3. Okay. Now, log both sides. Ln 15 to the power of x ln 2 over 3. So x larger than, I'm going to break this down, ln 2 minus ln 3 over ln 15. There you have it. That is the exact form. Okay, exact form. Expand 2 minus 3x to the power minus 2 in ascending powers of x up to and including x squared. Simplifying the coefficients. So before I expand this number here, 2 must be a 1. So what you need to do is you need to factor out the 2. 1 minus 3 over 2x or negative 2. So 2 to the power negative 2, 1 minus 3 over 2x to the power negative 2. 2 to the power negative 2 is 1 over 4. Expanding this. 1 plus negative 2 minus 3 over 2x plus negative 2 times negative 3 over 2 factorial. Refer this to the formulas that are given, okay? Minus 3 over 2x. So you're only expanding up to x squared. So this is 1 over 4, 1 plus 3x. So we can cancel. 3 over 2 square is 9 over 4 times 3 is 27 over 4. All plus, square. Expanding, you get 1 over 4 plus 3 over 4x plus 27 over 16x squared. There you have it. State the set of values for x for which the expansion is valid. Okay, for the expansion to be valid, the modulus of 3 must be smaller than 1. That means this value must be a proper fraction. Huh? So x is between minus 2 over 3. Okay. Express the equation tangent theta plus 60 equals to 2 plus tangent 60 minus 60 as a quadratic equation in tangent theta, hence solve the equation. So using the compound angle formula, tangent theta plus tangent 60 over tangent theta tangent 60 equals to 2 plus tangent theta minus tangent 60, sorry, minus tangent theta over 1 plus tangent 60 tangent theta. Okay, I'm going to move this over to the left hand side of the equation and simplify. Tangent 60 is root 3. So this is tangent theta plus root 3. 1 minus root 3 tangent theta minus tangent 60 is root 3. Root 3 minus tangent theta. This is minus over 1 plus root 3 tangent theta equals to, making it into a single fraction. So this times this. So this is tangent theta. Hopefully I got enough space. Plus root 3 tangent square theta plus root 3 plus 3 tangent theta 3 plus tangent theta minus plus 3 tangent theta minus root 3 tangent square theta. So this one you can cancel. This you can cancel. Okay. So this one you multiply up with 2. Huh? So 2 tangent theta plus 3 tangent theta plus tangent theta plus 3 tangent theta is 8 tangent theta. Equals to 2. This is 1 minus 3 tangent square theta times 2 minus 6 tangent square theta. Okay, now by simplifying, you get 3 tangent square theta plus 4 tangent theta minus 1. Oops, writing too fast. Equals 0. So factorizing minus 1 equals 0. Okay, let's see if there's any condition between 0 and 180. Theta equals to 1, 3. Theta equals to 1. So here you have theta equals to 5 degrees. Here theta equals to is one of the solution. Check the calculator. 18.4 degrees. Made a mistake by from my factorizing. It will not be so easy. Okay. You got to use the quadratic formula to find the solution. 0.215 is one of the solution. And minus 1.549. So solving this, you get 12.1 degrees. And so this is in the second quadrant, negative. So this is 1, 2, 2, 8 degrees. Okay. There we have it. Sometimes you have this problem of technical problem. Okay. Let's drop all this away. That's the equation tangent theta plus 60. Same problem again. Same problem. Okay, let's continue. Is having this problem. Come on. Okay. Let's look at the question again. Next question. Question 4. Question 4. Okay. The curve with equation y equals to e to the power of 2x sin x plus 3 cos x has a stationary point that equals 0 to pi. Find the x coordinate of this point, giving your answer correct to 2 decimal place. So when you want to find stationary point, you have to differentiate over dx equal whole e to the power of 2x. Differentiate sin x plus 3 cos x. So you have cos x minus 3 sin x whole sin x plus 3 cos x. Differentiate e to the power of 2x. So it's 2e to the power of x sin x plus 3 cos x. Okay. So if you simplify this, you get e to the power of 2x cos x plus 6 cos x, 7 cos x, minus 3 sin x plus 2 sin x minus sin x. Okay, when at the stationary point, dy dx is 0. So e plus 2x is not 0. So 7 cos x minus sin x equals 0. Here, when you have an equation in sin x and cos x, you divide by cos x, you get tangent x equals 7. So x equal. Now put your mode of your calculator in radian. So this is between 0 and pi only. So this is 2 decimal place. This is 1.43. Okay. 1.43. Isn't it coming out? Okay, let's see if it's working now. Yes. Determine whether the stationary point is a maximum or minimum. So there are 2 ways to determine. You can differentiate again. Would it be advisable to differentiate again? Maybe. Okay. Determine the whether stationary point is maximum or minimum. So you can always use values, but I would, since it's a trigonometry with exponential, is better to differentiate again. Again, whole e minus 7 sine x minus cos x plus 2e 2x 7 cos x minus sine x. So you have e to the power of 2x is minus 7 and minus 2. It's 9 sine x minus cos x plus 14 cos x plus 13 cos x. Okay, so when x equals to 1.43, you're interested if it's a positive or negative value. So it's a negative value. Therefore, maximum point. Okay, hopefully no more technical error. Find the quotient and remainder when 2x cubed minus x squared plus 6x plus 3 is divided by x squared plus 3. So what I'm going to do is you divide it by a quadratic, you do a long division. X cubed minus x squared plus 6x plus 3. X squared plus 3. So you times by x, you get, no, you times by 2x. 2x cubed plus 6x. So when you minus, you get minus x squared plus 3. So this is minus 1 minus x squared plus 3. So there's no remainder. So x squared plus 3 is and the quotient is 2x minus 1, remainder 0. So x squared plus 2 is a factor. Okay. Using your answer to part A, find the exact value. So you have this equal to quotient plus, so x squared plus 3 times 2x minus 1. So integrating 2x plus 1, you get x squared minus 9 minus 3 minus 0, 6. Okay, that's your solution. Okay, good. X squared. How come it's a 5-mark question? It's so easy. Let me have a look. 6x plus 3. Okay, sorry, I made a mistake. It's not a mistake. This is minus 3. I made a mistake. So always there's a check and balance. So this is minus 3. So the answer remainder is 6. No remainder. So here, okay, let's do it again. Okay. Times word does not allow you to use your fingers. So it's quotient quotient is 2x minus 1. Plus remainder, which is 6 over your divisor. Okay. So now they like to give this arctangent integration. So you have to refer to your MF19 for this integration. 1 over x squared plus a squared equal 1 over a arctangent x over a. Okay, so integration 2x, you get x squared minus x, okay, plus, so x squared plus a squared, so a is root 3, 6 over root 3, arctangent x over a, so x over root 3. 1. So careful, they want the exact value. So this is 9 minus 3 plus 6 over root 3. I'm going to simplify. Times root 3 over root 3 is 2 root 3. Tangent 3 over root 3. Minus 1 minus 1. 2 root 3 up. Tangent 1 over root 3. So this is 6. Arctangent 3 over root 3 is pi over 3. Minus 1 minus 1 is 0. Arctangent 1 over 3 root 3 is pi over 6. 2 root 3 pi over 6. So the exact solution is 3 pi over 6. That is your answer. Okay. That would warrant a 5-mark question. Okay, next question. Question on circles. The diagram shows a circle with center 0 and radius r. The tangent to the circle at the point A and B meet at T. And angle AOB is 2x radian. The shaded region is bounded by the tangent AT and BT and by the minor arc AB. The area of the shaded region is equal to the area of the circle. So the shaded region is it's 2 congruent triangles, AOT. Okay, it's 90 degrees, so this angle is X. AT tangent X equals AT over R. So AT equals to R tangent X. So the area of OATB is 2 times the area of the triangle AOT. So this will be just R tangent X times R, which is equals to R squared tangent X. And they say this is equal to no, not finished yet. So shaded region shaded region will be OATB minus sector OAB. Okay. So it is r square tangent x minus half r square times 2x, which is r square tangent x minus x. Okay, so this is equal to the circle by r square. So you can cancel the r square. And there we have it. Tangent x equals to pi plus x. Shown. The equation has one root in the interval 0 to half pi. Verify by calculation that this root lies between 1 and 1.4. So let fx equals to tangent x minus pi minus x. So you need to show that for f0 and f half pi, one is positive and one is negative. Remember to put your calculator in radian. Tangent 0 minus, this is just minus pi. Pi. Oh, okay. So it's not defined for tangent half pi. Tangent half pi is an infinite value. Okay. So this is just a positive infinite value. So one is negative, one is positive, of course. The root. Nice. F1.4, not half pi, sorry. This is 1. Sometimes sometimes you must read the question properly. Okay. F1 tangent 1 minus pi minus 1 minus 2.58. 1.4. 1.26 between 1 and 1.4. Okay. Good enough. Using the iterative formula, determine the correct 2 decimal place, give the result each iteration to 4 decimal place. So I would like to always solve my questions. So I will put the first approximation as 1.2, x1. So x2 1.34 decimal place, 1.3. X3 1.351. 1.5. X4 1.3518. Okay. X5 also 1.3518. Once you get 2 repeat answers, you can make your approximation as 1.35. Okay, good. Let fx equals to cos x over 1 plus sine x. Show that f prime x is smaller than 0 for all x in the interval minus half pi to 3 over 2 pi. So let's differentiate f prime x. This one using the quotient rule. Differentiate cos x is minus sine x minus cos x. Differentiate 1 minus 1 plus sine x is cos x. 1 plus sine x. So here you have 1. Oh, minus sine x. Minus sine square x. Minus cos square x. So I'm going to factor it out. This 1 plus sine x square. Square. So sine square x plus cos square x is 1. So this minus sine x minus 1. So I take the minus out, this becomes a plus. Plus sine x. Cancel this, I get minus 1 over 1 plus sine x. Negative. Okay. Now 1 plus sine x minus half pi. Okay, so it's not equal to negative 1. Is larger than 0 for x between minus half pi 3 over 2 pi. So f prime x minus 1 over sine x will be a negative value. Okay. So what does it tell you? It tells you that this is a descending function. Okay. Now integrate fx. Half pi 1 over 6 pi cos x over 1 plus sine x. If you know how to integrate this is in the form f prime x over fx dx. You get ln fx. So this differentiating 1 plus sine x, you get cos x. So the answer is ln plus sine x. Pi 1 over 6 pi. Sine of half pi is 1. So 1 plus 1 is 2. So this is ln 2 minus sine of 1 over 6 pi is half. 1 plus half is 3 over 2. 2 over 3 over 2 is 4 over 3. Ln 4. That's the answer. Thank you very much. Certain curve is such that its gradient at the point xy is proportional to y over x over x. The curve passes through the point with coordinates 1, 1, and 4e. So proportional means variation. Gradient is dy dx. Proportional to y over x over x. So when you change it to an equation, you introduce a constant. I put it as k. Now this is a differential equation. To solve this differential equation, what I'm going to do is separate the variable. So this will be dy over y equals to k. I'm going to bring this power up so that differentiate. This x times x power half is x3 over 2. So it's minus 3 over x. So this will be ln y equals to kx minus 3 over 2 plus 1 is minus half. Or minus half. Okay, I'm going to simplify further. Minus 2kx to the power minus half. C. Okay. First, I'm going to take 4e first, the point. 4e. I'm going to take this point. I'm going to take 1 first. Ln of 1 is 0. Ln 1 minus 2k c. C equals to k. For e. Ln e equals minus 2k 4 to the power minus half. Which is 2 over 2. Cancel the 2. C is 2k. So ln e is 1 minus k plus 2k. In terms of x. Ln y equals to minus 2 over x plus 2 minus 2 over x. Okay. This is the solution. Describe what happens to y as x tends to infinity. So I'm going to rewrite the function. This will be e squared over 2 over root x. Okay. X tends to infinity. X tends to 0. So y will tend to e squared over e to the power of 0. Towards e squared. That's your answer. Question on vectors with respect to the origin or the vertices of triangle ABC have position vectors or A, B, and OC. Okay, using a scalar product, show that the angle ABC is a right angle. So BA, vector BA, BO plus OA equal. We'll put it in column form. 2 minus 3, 2, 0, 5. This minus 1, minus 2, 2. BC, BO plus OC. 3 minus 2 minus 3 plus 1, 1, 1. Minus 2. Okay. So if there's a right angle, the dot product is 0. BA BC equals to 1 minus 2, 2 dot 2 minus 1 minus 2, sorry. 2 plus 2 minus 4 equals 0. Therefore, angle ABC is a right angle. Show that triangle ABC is isosceles. So you must show that the length AB and BC are equal. So the magnitude of ABA equal to square root of 1 square plus 2 square plus 2 square equals to 3. Magnitude of BC square root of 2 square plus 2 1 square, sorry, plus 2 square is also equal to 3. And therefore, triangle ABC is isosceles. Okay. A2 vectors questions are like AS previously. Find the exact length of the perpendicular from O to the line through BC. So the vector equation of the line BC see 1 1 1 plus S directional vector which is BC minus 2 minus 1 minus 2. So I'm going to just put 2 1 2 to make it positive. It's the same thing. Okay. So any point on the line BC will have position vector of 1 plus 2s, 1 plus s, and 1 plus 2s. Okay. Now, doing a dot product is the position vector and the directional vector will give you the perpendicular. Yes, just give you. This is this vector, position vector. This is B, C. This is a directional vector which is 2, 1, 2. So by doing a dot product, it will be 0. So when you find S, you will find the position vector. You find S, you find the position vector of the point. This point here, which is the foot. Okay. So I put this as OF. 1 plus 2S dot 1, 2 equals 0. 4s plus 1 plus s plus 2 plus 4s equals 0. So 9s equals to minus 5. S equals to minus 5 over 9. F equals to minus 10 over minus 1 over 9. 9 minus 1. So the perpendicular distance is just the magnitude. This is just 2. It's 18 over 81. Okay. 2 over 3. That's it. Complex number u is defined by u equals to 3i over a plus 2i, where a is real. Express u in the Cartesian form, u plus x plus iy in terms of a. So you need to rationalize the denominator. You multiply by a minus 2i. So this is 3i times minus 2i is 6 plus 3ai a square plus 4. So writing in the form that the question wants is 6 over a square plus 4 plus 3 over a square plus 4. Okay. Find the exact value of a for which argument of u is 1 over 3. This is a. Mr. A. Goes to 3a over a square plus 4 divided by 6 over a square plus 4. Okay, this will be equals to a over 2. Up tangent 1 over 3 pi is 3. A equals to 2 over 3. On a sketch of an argon diagram, shape the region whose points represent the complex numbers, satisfying this too. Okay. So when you have two complex numbers, inequality given by this is the perpendicular bisector. This is real. Minus 2i. Let's see, 2i is here. 1 plus I. Here. Okay. This is for the first one. Okay, this is equal. The other z minus 2 plus I. 2 plus I. 2 plus I is here. Smaller than 2. So it's a circle. With a radius of 2. Now, z minus 2i is here, is smaller. Smaller. That means it is on this side. This side. This is smaller than 2 is inside the circle. So it is this area here. Come always have technical problem. Hello. It's the last question already. So you're finishing. Seems to have a technical error. Okay. Okay. Over here. Okay. Okay. If you like lesson today, you can always put a comment and I will send over this paper to you. Please remember to put your email address, subscribe on this channel. Thank you and bye for now.